Good evening everybody. Today we will discuss about the lesson electricity. What is meant by electricity? We have some previous knowledge about this electricity in the 7th class. We know some symbols, how we will denote the electric symbols like battery, switch in on position, off position, bulb, etc. And the flow of charged particles is called electricity. How we will get that charged particles? Is every substance passes, electricity passes through them or not? To know that, we have to do some experiment. First complete a circuit like this with connecting wires. This is the bulb, this is the switch, and these are connecting wires which are made up of, covered by insulators which are made up of copper. When we on the switch, the bulb will glow, everyone know. Suppose if you take switch connection, battery, remove from the circuit, connect the wires and again observe, the bulb will glow or not? Definitely not. We know that one. Why? Because we need a source to glow the bulb. For suppose bulb is there, battery is also there, but change the connecting wires. In spite of copper wires, use nylon wires. What happens? In spite of copper wires, use nylon wires. Switch on. What happens? The bulb will not glow. So, by doing this experiment, we can conclude that to carry the charged particles from source to bulb, we need some conductors. Conductors means which allows charged particle passes through them are called conductors. Copper, silver, aluminum, all metals are used as conductors. But copper we will get very cheap and large quantity. That's why we will use most of the electric circuits are made up of copper. By having cover, insulating cover with them to reduce the discharge and shock effects. Next, if you take a open circuit, means you did not connect the two ends of that wire, what happens? If you observe a open circuit, all metals have free electrons, positive charges and free electrons, it has more. Metals have more free electrons, that's why all metals work as a conductors. But when the circuit is in open condition, in any cross section, the number of charged particle passes through them, any particles are equal in both sides. From how many numbers are number of charged particles moving from one cross section are equal to the number of charged particle passes opposite in direction. So, at charge will not get at any cross section in open circuit. But if you observe in a closed circuit, when you close the circuit with a battery, battery gives some energy. That energy makes the free electrons to move in a particular order. The energy makes the electrons to move in a particular order. Here electrons are charged particle which has negative charge. Like this. Lorentz and Root proposed this theory. Charged particles moves in a specified direction. So, at any cross section in that conductor, if you take some charge we will get some charge. Why? Because they all are moving in a specified direction. So, at any cross section, if you observe, the charged particles are there. So, to how many charged particles are moving there? That moving of charged particles is called electric current. Moving of electrons or moving of charged particles is called current. Okay. Not only the negative charge, positive charge also present in a conductor. The arrangement of positive charge in a conductor is called lattice. The arrangement of positive charges in a conductor is called lattice. Okay. In electric current is ordered motion of charges. Formula is I is equal to Q by T. Q be the charge of the charged particles and T be the time. The unit of electric current is ampere. Coulomb per second. Coulomb per second is ampere. Charge. The unit for charge is coulomb. The unit for time is second. Coulomb by second is the unit for the current. that we will denote it as capital A, ampere. Electrons moves opposite to the direction of electric field. When we connect the ends of a conductor to a battery, electric field is generated throughout the conductor. Immediately electric field is generated throughout the conductor. That electric field gives some energy to that electrons. So there is a change in their acceleration. They move in a specified direction, and when it is accelerated, it loses its energy and come to the stable position. But again, due to the electric field, again it gets acceleration and moves forward. Like this, the charged particles moves towards the conductor, to the length of the conductor. Throughout the length of the conductor, charged particles moves in this specified direction due to the force effect of electric field. Okay, how much electric field will be generated? What is the velocity of the charged particles? That is called drift velocity. For a copper wire, generally we will use copper wire, that's why they mention copper wire. If you take this by using this formula I, how much current passes through the conductor is I is equal to N, means number of charged particles. N means number of charged particles passing through a cross section at any time. Q be the charge of the particle, means here what are the charged particles, moving charged particles, what? Electrons. So charge of the electron. Here AVD gives you the volume of the cross section. See, if you take from here to here, if you observe, this is the length and this is the area. Area into length gives you the volume. The speed of the charged particle in 1 second gives you the distance travelled by the charged particles. Here distance becomes velocity. Velocity and distance becomes equal when it is moving it 1 second. In 1 second, how much velocity the charged particles moving is Vd. So that is the distance travelled by that charged particle in 1 second, Vd. Vd is the distance travelled. A is the area of cross section. Vd into A gives you the volume of that cross section. Then we want to know the drift velocity of the charged particle. Vd is equal to I by NQA. For suppose for a copper wire, experimentally proved density, electric density of the copper is 8.5 into 10 power 28 per meter cube. What does it mean? The number of charged particles, N means in 1 meter cube volume, the number of charged particles present in a copper wire is 8.5 into 10 power 28. Q is the charge of the charged particle, that is equal to the electron charge. Movement of electrons is called current. The moved particles are electrons. So the charge equal to the electron charge, that is 1.602 into 10 power minus 19 coulomb. By calculating this, you can get drift velocity of the electron for a copper wire is 7 into 10 power minus 5 meter per second, that we convert into millimeters per second, that is 0.07 millimeter per second. That is 0.07 millimeter per second, means electrons are moving very slowly. The drift velocity of the electrons for a copper wire is 0.07 millimeters per second. Next, potential difference. What is a potential difference? Work done by electric force on unit charge, W is equal to Fe into L. Fe means here electric force, L means the length of the conductor. L means the length of the conductor, Fe means the force, electric force. The work done means, suppose if you take this is a electric conductor, to move one unit positive charge from one end to the other end, how much work has to be done? That is called potential difference between the two ends. We will calculate the potential difference between two ends of a conductor or two ends of a electric device. Two ends must be, we have to consider. See, Work done by electric force on unit charge is W is equal to Fe into L. Work done by the electric force on unit positive charge to move it through a distance L is called potential difference. Here the length of the conductor is the L. The distance is the length of the conductor. So potential difference V is equal to W by Q, that is equal to Fe into L by Q. Then what is the units of potential difference? Potential difference units are volt, that is equal to 1 joule per coulomb. C means coulomb. 1 joule per 1 coulomb is called 1 volt. Next, EMF, electromotive force. For suppose for the source of, in spite of source of electricity, we are using batteries in circuit. That time the battery, in battery chemical energy is converted into electrical energy. So the energy given by the battery is called chemical energy. So work done by the chemical force to move one unit positive charge from negative terminal to positive terminal. In a circuit, from a negative terminal to positive terminal, how much energy, how much force used to do work? What is that work? To move one unit positive charge from negative terminal to positive terminal. The work done is called electromotive force. That is, electromotive force is also have the same units of potential difference volt. But here W by Q, that is work Fc into L by Q. C means chemical force. Here electrical forces is for EMF Fc into L by Q. Fc means the chemical force. Ohm's law. What is Ohm's law? Ohm is a German scientist. He find the relation between the potential difference and current flow through it in a conductor. What is the relation between the potential difference and current passes through them is proportionality. Potential difference between the ends of the conductor is directly proportional to the current passes through it at constant temperature. If the temperature is changed, the resistance of the conductor also changes. That's why at constant temperature, the potential difference at the two ends of a conductor is directly proportional to the current passes through it. That is called Ohm's law. Experimentally it is proved. V is proportional to I, and otherwise we can say it as V by I is equal to constant. For all conductors or for all substances, this rule is applicable or not? Let us see. For which substances are obey the Ohm's law, those are called ohmic substances. Some substances do not obey the Ohm's law, those are called non-ohmic substances. All metals are works as ohmic substances. All metals follows the Ohm's law, means V is proportional to I. If you take potential difference in x-axis and temperature in y-axis, potential difference in x-axis and electric current in y-axis, if you draw a graph, that always you will get a straight line which is passing through from the horizon. Those are called ohmic substances. So they are obeying the Ohm's law. For example, germanium, silicon like semiconductors. Germanium, silicon are semiconductors. And LED, light emitting diode, these are not following the Ohm's law. That's why we can call them as non-ohmic substances. Which obeys Ohm's law are called ohmic substances. Example, all metals. Which do not obey the Ohm's law are called non-ohmic substances. Example, LED, germanium, silicon, etc. For them, if you draw a graph in x-axis potential difference and in y-axis current, you will get a curved line. Means they do not obey the Ohm's law. From the equation V is proportional to I, then V is equal to IR, means I into some constant or R is called proportionality constant. Here R is called resistance. R is equal to V by I. Resistance. What is resistance? The substance which do not allow the moving particles, which does not allow the current passes through them, are called resistors. Which does not allow, which opposes the motion of the charged particles, are called resistance. Here R is equal to V by I. The units of R resistance is ohm. OHM, ohm. Resistance of this is the symbol for the ohm. This is the symbol for the ohm. Ohm is equal to volt per ampere. Ohm is equal to volt per ampere. The resistance also has a symbol to denote that one. We will denote resistance in this symbol. This is called symbol of resistance. The unit of symbol for resistance we are having a unit that is ohm, that is denoted by this symbol ohm. This is the symbol of resistance. So ohm is equal to 1 volt per 1 ampere. Next, multimeter. Okay, multimeter is a device to measure the current, resistance as well as potential difference. By using that instrument we can measure the current either in AC supply or DC supply. We can calculate the potential difference and resistance also. How much resistance has that conductor also we can measure by using a multimeter. To measure the potential difference we use voltmeter. To measure the current passing through a circuit we use a device ammeter. Ammeter we must connect always in series connection. Ammeter we have to connect in a circuit in series connection. Voltmeter always we have to connect in parallel connection. Why? Because in series I is constant, in parallel connection potential difference is constant. Let's see, electric shock. What is electric shock? The combined effect of resistance, current and potential difference is called shock. The shock is the combined effect of potential difference, current and resistance is called shock. So for suppose every person have a experience of shock. Nowadays to reduce that shock we are using some shock absorbers and fuse shock absorbers we are using. But electric shock, in an electric circuit if any resistance is less, the combined effect of resistance and potential difference, current is called shock. For a human body, in a human body is acts also conductor. It has the resistance varies from 100 ohms to 5 lakhs ohm. So for wet clothes, wet salt water clothes like that, because of the position of the human body, resistance varies from 100 ohms to 5 lakhs ohms. For suppose calculate the how much current passes through them if we have 1 lakh ohms resistance. The general current supply to the household activities is 240 volts. Resistance of a human body, take it as 1 lakh ohms. Now how much current passes through them? By using the formula, from the formula V is equal to IR, we can calculate the I is equal to V by R. Here V means 240 volts, potential difference 240 volts and resistance is 1 lakh ohm. What happens? You will get 0.0024 ohms, 0.0024 amperes current. Current passes through a human body 0.0024, just we can identify some energy passing through us. For suppose the 0.001 ampere current passes through them, we can identify the difference. For suppose 0.005 amperes of current passes through us, it will be painful to us. 0.010 amperes of current passes through them, it causes involuntary muscle contraction, muscles compresses. In our body inner parts, muscles will be compressed. At 0.015 current passes through the human body, it causes loss of muscle control. So for suppose the current 0.015 amperes current passes through a human body, we will lose our body control, muscles control, we will lose muscle control. So our body parts are not in our control. 0.07 amperes of current passes through heart. Always current selects the least path to travel. In the manner it passes the current 0.07 amperes of current passes through a human body more than 1 second, the person will be fatal. More than that time it passes through means it causes for death. Next, factors affecting resistance. First one is temperature. If the temperature becomes more, the resistance also, there is a change in its resistance also. Resistance also becomes more. So R is proportional to L, means the length of the conductor. If the length of the conductor is increased, the resistance also increases. R is proportional to 1 by A, means inversely proportional to the area of cross section of the conductor. What does it mean? If area of cross section becomes more, resistance becomes less. If the area of cross section is very less, then the resistance becomes more. Inversely proportionality to the cross section area. Resistance is directly proportional to the length of the conductor and resistance is inversely proportional to the area of cross section. Then R is proportional to L by A. R is equal to rho L by A. Here rho is called the proportionality constant, thus is called specific resistance. It is depend upon the nature of material. Rho is called specific resistance. It is depend upon the nature of material. Specific resistance, rho is called specific resistance. The units of rho is ohm meter. How you will get that ohm meter? Let us see. From the equation R is equal to rho L by A, we have to calculate rho. What happens? Do cross multiplication. Rho into L. Rho L is equal to R into A. Rho is equal to R A by L. What are the units of R? For resistance, ohm. For units, A means area, meter square. By L means length, units is meter. 1 meter cancels, ohm meter. So what is the units of specific resistance? The units of specific resistance is ohm meter. The reciprocal of resistivity is called conductivity. The reciprocal of resistivity is called conductivity. The unit of conductivity we will denote with sigma. Resistivity we will denote with rho. Conductivity we will denote with sigma. The units of sigma means the units of conductivity is called mho. MHO, mho. In series connection, the final resistance of the resistors is the sum of the resistors in the circuit. R is equal to R1 plus R2 plus R3. For suppose there are 3 resistors of 1.5, 3 and 5 ohms connected in a series connection. What does the meaning of series connection? The positive terminal of the first resistor is connected to the negative terminal and the negative terminal of the resistor is connected to the positive terminal continuously in a chain process. If you connected means that is called series connection. In series connection, the final resistance, resultant resistance R is equal to R1 plus R2 plus R3. For suppose 3 resistance of 1.5, 5 ohms of resistance connected in series connection, the final resistance will become R is equal to 1.5 plus 3 means 4.5. 4.5 plus 5, 9.5 ohms. The final resistance will become 9.5 ohms. For suppose in series connection, 10 resistors of equal resistance connected in series connection. 10 resistors of equal resistance means what does it mean? The number of resistors n is equal to 10. The resistance for each R is equal to R ohms. We don't know that one. Then how can we calculate? By using this formula, you can write that R1, in spite of R1, you can write R. R plus R, how many times? 10 times. So that is 10R. Answer you will get 10R. You have to multiply the one resistance with the number of resistors, 10R. Suppose if you want to tell this in a problem, in a formula, if equal resistance, all resistance are equal, then the final resistance R is equal to NR. Resultant resistance RR is equal to NR. In the same way, in parallel connection, the final resistance 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 etc. By using this formula, we can calculate the final resistance. While doing the problem, after completion of the solution, we have to reverse to know the resistance. Why? Because 1 by R this is. You will get also the value of 1 by R, but you have to know the value of R. Therefore, R is equal to, you have to reverse the answer. For suppose the R1, R2, R3 all are equal. What happens then? 1 by R is equal to N by R. But we want R. So, resultant resistance R is equal to R by N. For suppose all resistance is equal, they are connected in parallel, then we have to use this formula. Resultant resistance R is equal to R by N, resistance by the number of resistors in parallel connection. In series connection, number of resistors into resistance, equiresistance. Next, Kirchhoff laws. Kirchhoff laws are only applicable for the DC circuits only. Here we are having two laws. The one is junction law and another one is the loop law. In junction law, in a junction, how many number of currents reaches the junction is equal to the number of currents passes through them. At junction, the current will become 0. The geometric sum of the currents becomes 0. That is in a junction. In a junction, the geometric sum of current is 0. Means how much amount of current reaches the junction, the same amount of current passes through the junction. So, at junction, the current will become 0. The geometric sum of the current is 0. For example, if you say here, see, I1, I2, I3, I4, these are passing towards the junction. This is the junction. These all are passing towards the junction. And I5 and I6 are passing away from the junction. So, I1 plus I2 plus I3 plus I4 is equal to I5 plus I6. The sum of the currents passing towards the junction equal to the sum of the currents passing away from the junction. Otherwise, the geometric sum of the currents at junction is 0. That is called junction law. Loop law. What is a loop law? In a closed loop, the potential difference is, see, observe here, we are having one battery, this is a potential difference. Here we are having resistance. At the ends of this resistance also we have the potential difference. The sum of the potential difference is, how many potential difference are there also? All are equal. That is called loop law. The geometric sum of the potential difference is 0. The geometric sum of the potential difference in a closed loop is 0. That is loop law. Here we are observing a B, C, D, E, A is a loop. To know loop, to find the potential difference, we have to know the rules, how we have to give the sign conversion to them. See, here we are having that sign conversions. See, this is the loop direction. In loop direction, the battery positive to negative is there. Then we can take it as negative, positive to negative. The loop direction is from positive to negative. We can take the potential difference at that battery be negative. For suppose loop direction is like this, and the battery is from positive to negative. Means what does it mean? The current passing from the negative to positive. So we will get the positive. Here from positive to negative. Therefore that is negative. In loop direction we can take it as positive to negative, negative. Opposite to the loop direction from negative to positive. Negative to positive you can take it as positive. In a resistance, the potential difference between the ends of the resistance in loop direction, the current direction and loop direction are in same direction, you can take it as negative. But the current direction and loop direction are in opposite direction, that you can take it as positive. Let us take an example here. If you see, this is the loop direction. We are considering the loop as A, B, C, D, E, A. So, this is the loop direction. Loop direction like this. The battery direction, if you observe battery from positive to negative, from positive to negative. Therefore, what we have to take? V1 becomes negative. At the ends of the battery, the potential difference become negative. So, C minus V1. Potential difference at battery is negative, that is V1. Then here we are having resistance. So here we are having again potential difference. We know the formula V is equal to IR. The resistance of this current passing through this loop is I1. This is the current direction, and the resistance is R1. Then what will be the potential difference between these two ends of this resistance? I1 R1. V is equal to IR. By using that formula, the potential difference between these two ends of this resistance is I1 R1. Let us say this is the loop direction and this is the current direction. See, this is the loop direction and opposite to the current direction. So potential difference we have to take it as positive. So plus I1 R1. Then what is the loop law? The sum of the potential difference in a closed loop is 0. What does it mean? Then minus V1 plus I1 R1 is equal to 0. By using that formula, minus V1 plus I1 R1 is equal to 0. You can take this minus value from right side. What happens? I1 R1 is equal to V1. Otherwise V1 is equal to I1 R1. So the potential difference at the ends in a closed loop is equal, or the sum of the potential difference in a closed loop is 0. The loop law is proved. Electric power. The formula for the electric power is P is equal to V into I. P means power of the device. V means potential difference. I is the current passes through it. Then by using Ohm's law, in spite of V, we can write IR. V is equal to IR. By using that formula, you can write in spite of V, IR. And into I square R. We can convert the formula from V into I to I square R. In the same way, in spite of I, you can write V by R. So V into V by R, you can get V square by R. These formulas are useful to solve the problems. P is equal to EI also. Here E means the electromotive force. Here E means the electromotive force and I is the current. Unit of electric power consumption, how much we are using from the device is known as kilowatt hour. Kilowatt hour power consumption. 1 kilowatt hour is called 1 unit. For our household activities, you will get current bill every day. 150 units of current you used, 200 units of current you used. What is that unit? 1 kilowatt hour is called 1 unit. 1 kilowatt hour is called 1 unit. That is equal to the 3.6 into 10 power 6 joules. That is equal to the 3.6 into 10 power 6 joules. Sometimes they will give 35 into 10 power 5 joules also. Overload. What is meant by overload? In our house, we will use so many electrical devices like bulbs, fans, iron box, freezer, electric motor, geyser, etc. Like so many number of electrical devices we will use. The current passes through our household activities is 20 amperes. The potential difference is 240 volts. But if you are using all these electrical devices at the same time, what happens? The current, the incoming current is 20 amperes. But you are using more than the 20 amperes, what happens? It is called overload. Means the using the current more than the required, more than coming is called overload. Due to that overload, electrical devices will be damaged. So, to reduce the overload, what we will use? We use electric fuse in circuit. That fuse we will connect in series connection. That fuse must have the low melting point and high resistance. Which material has high resistance, that immediately becomes heat. So, the material has the low resistance point, then immediately it melts and breaks the circuits. So, the circuit will become open, so there is no current passes through the circuit. The household devices will be in safe position. When you are applying fuse in our house, that fuse must be in connecting series connection. Why? Because series connection has only one path. Suppose you are using parallel connection, it will go in another way. It has more than one paths. In parallel connection, current to passes through the current, it has many ways. So always we have to connect fuse in series connection. The quality of the substance using as fuse are the low melting point and high resistance. In spite of fuse, nowadays we are using MCBs also, that is MCB means miniature circuit breaker. In spite of fuse, we are using MCB. MCB means miniature circuit breaker. Next, electric energy is product of power and time. The product of power and time gives you the electric energy. The unit of electric energy is watt second or kilowatt hour. The unit of electric energy is watt second or kilowatt hour. Thank you.